In this video, we're going to look at another example of a rule that is used within differentiating a function. So previously we've looked at the power rule, the product rule. Now we're going to look at what's called the quotient rule. How I said earlier in the first video that we had for this section that we could have used the quotient rule straight away to derive that original function and how it got messy, we're actually going to see how that quotient rule plays out. And similarly to how the product rule has a form that it follows, the quotient rule has a form that it follows. And over here I made a note that h is going to represent the high function in this little rhyme that I'm going to give to you guys. So h of x is going to be our high function, and g of x is going to be our low function. Okay? And this is how the form of the quotient rule will follow. It'll look something like this. G of x times h prime of x minus h of x times g prime of x over g of x squared. Now, I used the names of the functions. You're probably wondering, well, why'd you take all that time to specify high and low? Well, the reason is because trying to remember this can get kind of confusing. So when I learned how to take derivatives, my calculus teacher taught me a little rhyme that I like to keep in my head, and this helped me a lot throughout the process of calculus, Cal 1, Cal 2, Cal 3, what have you, and just try to remember the quotient rule and what it looks like. So it says that you take, when using the quotient rule, you have low d high minus high d low all over the square of what's below. Okay? So you can use that rhyme if you want to. You don't have to. It's not going to appear anywhere on a test or anything like that, I'm for sure. But it's just a good way. It's just a fun rhyme that you can use to try to jog your memory of what the quotient rule will look like from time to time. So as long as you get straight what your high and your low is represented by, you can use that rhyme. So it says low d high minus high d low all over the square of what's below. Okay? So now that I've introduced you to that, in order to use the quotient rule, just like we did with the product rule, we have to check that the two components that compose our fraction, namely here the numerator and denominator, are both individually differentiable, which we see that they're both quadratics, and we know that when we have to derive a quadratic by itself, we can use the power rule. So this part's differentiable, this part's differentiable, so we're good. We can use the quotient rule. So we just need to get our derivative to look in this form. So what we're going to do in order to do that is just like we did with the product rule, we're going to come over here and do some deriving of our two pieces individually and then plug them into what our quotient rule looks like. So h of x is 4x squared minus 17x minus 9, and g of x is 2x squared plus 15x minus 3. So here we have h prime of x, which we can, like we said, we can derive using the power rule. So we're going to bring this power down, so we get 2 times 4, which is 8x, 2 minus 1 is 1, so we have 8x. Then we get minus 17x to the 1, so we know when we have x to the 1, the derivative of that is going to cause this x to go away, and this 17 is going to become a constant. The derivative of a constant is 0, so this is our derivative for h. For g prime of x, it follows the same pattern. We're going to take the derivative of 2x squared, so we get 4x. And we're going to take the derivative of 15x, which is going to leave us with just 15. So we have the four pieces that we need. So what we're going to do now is come over here, write our f prime of x down, plug those pieces into the puzzle, and see what our derivative is. So f prime of x, the first thing that we have is the low function, which is g of x. So we have 2x squared plus 15x minus 3. And this is going to be multiplied by d high. So the derivative of high was 8x minus 17. So now what we have is we're going to subtract the entire product of high d low. So what I like to do in order to not lose this minus and only distribute it in one spot where it needs to be distributed across the whole thing, I like to separate this with a bracket, and then if I'm going to simplify or if I have to simplify this product, I distribute the negative in along that process or after it just so I don't lose track of it. But here we have high. So the high function was 4x squared minus 17x minus 9. And then we have the last piece was d low. So d low is 4x plus 15. It times 4x plus 15. So that caps off our product. We end the bracket. And this is all going to be over the square of what was below. So what we're going to do is we're going to simply write 2x squared plus 15x minus 3 squared. So like we said earlier, you don't have to fret about doing all this multiplication and doing all that kind of good stuff to simplify the derivative. Once we get to this point and we match the form of what the quotient rule should look like, we don't have to do any more simplifying. There could come up problems later on in Cal 1, maybe even Cal 2, where once you get to this part, it may help you to simplify something that looks like this to move further on in the problem. But as of right now, we're just focused on using the different rules to find our derivative. So this function and the way that it looks is perfectly fine and dandy.